Hello everyone, welcome back to my channel. So today we're going to see another very important program, that is problem number 34 from the sheet, which is rainwater trapping problem. This is a very important problem, guys, so make sure you understand every bit of it. So without wasting any time, let's get into the video. So this is the problem which opens up once you click the link given in that sheet. This rainwater trapping problem is a medium level problem, as you can see. In LeetCode, it is mentioned as hard level. So yes, this is a tough problem in terms of logic. Thinking logic for this is a bit difficult, but don't worry, we'll walk through this problem together. So let's quickly go through this problem first and understand what it is trying to say. It says, given an array of n non-negative integers representing the height of the blocks. So the array which is given over here is representing the height of the blocks. Okay, so this block is for height 4, this block is for 0, this is for 2, this is for 0, this is for 0, and this again is for 3. Okay, so the array which is given over here represents the height of the block. Okay, and there are 6 blocks. So we understood the input over here. If width of each block is 1, means the breadth of each block is only 1. Okay, it's standard. Compute how much water can be trapped between the blocks during the rainy season. So during the rainy season, how much water can be trapped in between the blocks, that we need to see. So can you think of something? Just pause this video for a moment and think what are the points which are coming into your mind? How can you solve this? Okay, so let me tell you like how we need to proceed through this problem. We need to proceed block by block. Okay, so what you can think of? Can we store water in block whose height is 4? No, right? Because this block, which is of height 4, doesn't have any boundary on the right hand side, right? So if we fill the water over here, like it will overflow, right? Yeah. So we can't store the water in the block whose height is 4. Now comes the second last block, which is having a height of 0. So how much water can be stored over here? So think of the block which is of the greatest height on the right side of the present block and the block which is of greatest height on the left side of the present block. Okay. So what is the greatest height on the left side of the current block? It's 3, right? Yeah. And on the right side, how much is it? It's 4. So on the right side, the maximum height is 3 and on the left side it is 4. So we can, if we store the water till 4, till height 4, what will happen? It will overflow, right? Yeah, it will overflow. So what we need to do, we need to find the minimum of the maximum height between left and right blocks. Okay. So 3 and 4, what is minimum? It's 3. So we need to store water till height 3. As you can see, it's given over here 3. Okay. So now comes the next block, that is the block which is having a height of 2. So how much water can we store over here? Again, we need to follow the same procedure. We need to find the block of maximum height on the left side and on the right side. On the left side, it is 4 and on the right side, it is again 3, right? So we need to find the minimum among these two, which is 3. And how much water can be stored over here? It's the present block height, the like 3 minus 2. the present block height is 2, right? So 3 minus 2, that is 1 can be stored. So they have given over here 1. Fine. So now comes the next block, which is of height 0. So how much water can be stored over here? Again, we need to find the maximum height of the block on the left side and on the right side, which is 4 and 3. Minimum on these is 3. And again, we need to subtract this 3 with the present height of the block. That is 3 minus 0, that is 3. So again, it comes 3 for this particular block. So now again comes the next block, which is again for height 0. Again, we need to follow the same procedure. We need to find the maximum maximum height block on the left side of the present block and on the right side of the present block. So on the left side it is 3 and on the right side it is 4. Now we need to find the minimum of the two, that is 3 and 4. What is the minimum? It's 3. So how much water can be stored now? It's the 3 minus 0, that is 3. So this particular block can store water up to height 3, as you can see over here. And the last block, which is of height 3, we can't store any water over here. Why? Because it doesn't have any boundary on the left side of it. Okay. I hope you understood this problem, but don't worry, we are going to dry run this problem. So let's quickly get into it. I have taken the same example over here, which we were referring previously. Over here, as you can see, there are 6 blocks, each of height 3, 0, 0, 2, 0 and 4. Okay. So over here, what we need to find? We need to find the maximum height for each block on the left side and on the right side. Right? So how can we do that? We can do that by running a loop for each block. Right? For each block, we can run one loop for finding the maximum height on the left side and another loop for finding the maximum height on the left side. Right? So if we do that for each block, it will lead to a time complexity of n square, which is quite high. So in order to reduce that, what we can do, we can take two arrays. Suppose the name of the two arrays is max left and max right. Okay. So in these two arrays, we can store the maximum height of the blocks on the left side of the current block, including the current block, and in max right we can store the maximum height on the right side of the current block, including the current block. Okay, I repeat, max left is going to store the maximum height on the left side of the current block, including the current block, and max right is going to find the maximum height on the right side of the current block, including the current block. Okay, so let's start filling these two arrays, which is max left and max right. So for the 0th index, that is having a value of 3, so we can see like there's nothing on the left side of it to compare, right? So the maximum height till now, like till the 0th index, that is including 3, it will be 3 only, because there's nothing to compare 3, right? So if we go to the first index, which is having a height of 0, so what is the maximum height till the 0th index? It's 3, right? So if we compare 3 with 0, which is maximum? So till the first index, the maximum height is 3 only, right? And for the second index, again we'll compare. So till the first index, we have got the maximum height as 3. So if we'll compare 3 with 0, obviously 3 is maximum. So till the second index also the maximum height is 3. Okay, so now if we come to the third index, which is having a height of 0, we'll again compare if the maximum height which we got till the second index, which is 3, is maximum, or the present height is maximum, 2 is maximum. Obviously 3 is maximum, so it will be 3. So again, for the fourth index, we are again going to compare whether the maximum height which you got till now, which is 3, is maximum, or the present height, which is 0, 0 is maximum. Obviously 3 is maximum over here. Now for the last index, that is for the fifth index, again we are going to compare. So the maximum height which you got till the fourth index is 3. So which is maximum? Is 3 maximum or 4 maximum? Obviously 4 is maximum. So for the fifth index, the maximum height is 4. Okay. So now we are going to see the max right. That is the maximum height on the right side of the current block, including the current block. Okay. So on the right side of the fifth index, that is having a value of 4, there is nothing, right? There is nothing to compare. So it is including the current block. So till the last index, till the fifth index, 4 is the maximum height. So now if we decrement the index, it will come to the fourth index, which is having a value of 0. So now we'll compare which is the maximum height over here. So till the fifth index, we got the maximum height as 4. So which is maximum? Is 4 maximum or the current height, which is 0, 0 maximum? Obviously 4 is maximum. So till fourth index also we got the maximum height as 4. So now let's investigate about the third index. For the third index, what is the maximum height? So as we can see, till the fourth index we have got the maximum height as 4, right? So for the current index, which is maximum? Is 4 maximum or 2 maximum? Obviously 4 is maximum, so we'll keep it as 4. So now for the second index, which is maximum? It's 4, right? How? Because the maximum height which you got till now, that is till the third index, is 4. So for the second index, height is 0. So which is maximum? 0 is maximum, 4 is maximum. Obviously 4 is maximum. So till now the maximum height is 4. Yes. So now for the first index, again the height is 0. And the maximum height we got till now is 4, right? So which is maximum? Is 0 maximum, 4 maximum? So obviously 4 is maximum. Yes. So now comes the 0th index, which is having the height of 3, and till now, till the first index, we have got the maximum height as 4. So which is maximum? Is 3 maximum or 4 maximum? Obviously 4 is maximum. So the maximum height on the right side of the 0th index, which is having a value of 3, that is the height of the first block is 3, and the maximum height on the right side of it is 4. Okay, I hope you have understood this. So let's proceed with the further logic. This is the logic for finding the maximum height of the block on the left side and the right side of the current block. Okay, firstly I want to ask you all, are we going to store water on the first and the last blocks? Will we be able to store water on the first and the last block? No, right? Because there is no boundary on the left side of the first block and on the right side of the last block. Yes, and in order to store water, we need a boundary on both sides of it, right? So we are going to start traversing from the first index and not the 0th index. Why? Because there is no chance we can store water on the 0th index block. Okay, because there is no boundary for this on the left side. Okay, so for the first index block, which is having a height of 0, what do we need to do is we need to find the maximum height of the block on the right side of it and on the left side of it. So on the left side of it, the maximum height block is 3, right? And on the right side of it, the maximum height of the block is 4, right? It's 4. We can get it directly from these two arrays. There's no need to run a loop as we have discussed earlier. So now what do we need to do? We need to find the minimum among these two, which is 3. So why do you think we are finding minimum among these? Suppose we store water till the height of 4. Okay, till the height of 4. And the left boundary is just 3. So that if you are storing 4 liters of water and the left boundary is just 3, that 1 liter of water will just overflow. You need to think it, you need to imagine the scenario. Okay, so that's why we are finding the minimum among these and storing it in minimum variable. Okay, so now how much water can we store? We can store water up to the height of the current block, right? Up till the height of the current block, we can't store the water, right? So what do we need to do? We need to subtract. That is 3 minus 0. We can store water up to height 3, but what is the height of the current block? It matters, right? So 3 minus 0 is 3. So it's 3. So we can store water up till the height of 3. Okay, over here. So we can write it over here, it will be better. At last we are going to add it. Okay, so now we will proceed to the next index, that is the second index. For this again we need to find the maximum height on the left side, which is 3. Okay, 3. And we need to find the maximum height of the block on the right side, which is 4. Okay, now we need to find the minimum among these two, which is 3. Yes, so now we can store water up to a height of 3, but what is the height of the current block? It's 0. So we can store complete 3 liters. So it's again 3 for this block. We can store water till height 3 for this block. So now we'll proceed to the next index, which is the third index, which is having height of 2. Okay, so again we need to find the maximum height on the left side of the current block, that is 3. Okay, and the maximum height on the right side of the current block, which is 4. Okay, so now we need to find the minimum among these, which is 3 again. So now we can store water up to a height of 3 meters, or we can store 3 liters of water suppose, but the current height of the block is 2. Already the height of the block is 2 meters. So how much water can we store more? So 3 minus 2, that is 1. Only 1 liter can be stored. Only this much space is there. Okay, so here we can store just 1 liter of water. Okay, so now we'll proceed to the next index, which is the fourth index, which is having a height of 0 again. Okay, so we'll see the maximum height of the block on the left side of the current block, that is 3 again. Okay, and on the left side of the current block, which is 4 again. Okay, so now we need to find the minimum among these, which is 3. Okay, so now we need to see how much water can we store over there. We can store water up to a height of 3 meters, right? Up to a height of 3. But what is the height of the current block? It is 0. So 3 minus 0 is 3. So we can store complete 3 liter of water, or complete height. We can store water up to the height of 3. meters. Okay, so now we'll proceed to the next index, which is the fifth index, which is the last index. And in the last index, as we discussed, that there's no possibility to store water over there because there's no right boundary for the last index, right? So here we are going to stop at processing. So what we got these values. We need to add these values up. It will add and give it a value of 10. So the total water we can store over here is 10 liters. Okay, I hope you understood this. So let's quickly see the algorithm for this, and then we'll see the code. Let's see the algorithm now. So the first step is we need to create two arrays, say max left and max right, in order to store the maximum height on the left side of the current block and on the right side of the current block respectively, including the current block. So what it says, we need to take two arrays, which is max left and max right. You can name it whatever you want. So max left is going to store the maximum height on the left side of the current block, including the current block, and the max right is going to store the maximum height of the block on the right side of the current block, including the current block. Okay, so this is the first step. So next, what do we need to do? We need to run the loop from the first index till the last but one first index. Understood? Like, we don't have to run the loop from the 0th index. Why? Because there is no possibility to store the water on the 0th index, because there is no boundary on the left side of it. Okay, and we need to run the loop till the last but one index, because we can't store water on the last block because there is no boundary on the right side of it. Okay, so this is the second step. We need to run the loop from where to where we know it, right? Okay, so now comes the third step. On the third step, what do we need to do? In the third step, we need to find the maximum height of the block on the left side and the right side of it using the max left and the max right arrays. Okay, so for the current block, we need to find the maximum height on the left side of it using the max left array, and we need to find the maximum height on the right side of it using the maximum right array. Okay, so we are clear with the third step as well. So now in the fourth step, we need to check whether both the heights which we got, both the maximum heights which we got on the left and on the right side, we need to check whether both these heights are more than the current height of the block. Okay, if both the heights which we got as the left and the right boundary are more than the current block height, then we need to proceed. What do we need to do then? We need to find the minimum among the two maximum heights which we got, and then we suppose we are storing it in min variable. Okay, so here it is written as if both the maximum heights are greater than the current block height. Okay, then we need to find the minimum among the two maximum heights and store it in min variable. Okay, now we need to subtract this min with the current block height in order to know how much water can exactly be stored in that block. Okay, what do we need to do? We need to subtract that min which we got with the current block height, so that we will be knowing that till how much height can we exactly store the water. Okay, we can store water till minimum height, which is stored in min variable. Okay, but this current block might have occupied some height, right? It might have some height, so that's why we are going to subtract the minimum with the current block height, so that we come to know how much water can exactly be stored in that block. So now we'll proceed with the code for this. Let's start coding the solution. We are going to follow our algorithm step by step over here. Okay, So first let us change it to Java because we are going to code in Java. Now first we'll take two integer arrays, which we can name it as max left and max right. Both the length of both the arrays is going to be the same, that is n, which is the length of the array which is already given. Now first we'll populate max left array. As you remember, max left array needs to be populated from left to right. So first we'll initialize the 0th index of max left array with the 0th index of the array which is already defined. Then we are going to run the loop from first index till the last index, and we are going to compare if this max left of I minus 1 is greater than the array of I, then we need to assign max left of I as max left of I minus 1, which is maximum. Okay, else we need to assign the current index of max left with the current index of array of I. Okay, so we are done with max left initialization. Now I'll proceed with max right initialization. So as we know that max right array needs to be populated from right to left. So max right of n minus 1, we need to initialize n minus 1th index of max right with the n minus 1 index of the array which is already defined. Now we need to run the loop from n minus 2, okay, till 0, and similarly we need to compare if the previous index of max right is greater than the current index of the array which is already defined, then we need to assign the current index of max right with the previous index of max right. Else we need to assign the current index of max right with the current index of the already defined array. Okay, so now as our both the arrays are completed, so we now have the list of all the all the left boundaries and the right boundaries of all the blocks. So now we'll proceed with the processing. So for that, what do we need to do? We need to take an array, we need to take a loop which will run from the first index till the last but one index. Reason you already know that, I have repeated it many a times in this video, because the first and the last block cannot be filled with water. Okay, why? Because it doesn't have the boundaries. In order to fill a block with water, we need to have boundaries on both the sides, right? So that's why. Now we need to compare if the left boundary, that is max left of I minus 1 is greater than error of I, and at the same time the right boundary of the current block is also greater than the current block height, then what do we need to do? We need to start our main processing. What do we need to do over here? If the left boundary is also greater and the right boundary is also greater, means we need to find the minimum over here, which will be math.min of max left of I minus 1 comma max right of I plus 1. So we have the minimum of the two now. So now what do we need to do? We need to take a result variable which is of long type, because we need to return the result in long. We'll initialize it with 0. Now we need to add this minimum to the resultant array. How? We need to subtract the minimum with the current block, and don't forget to return the result. So we are done with the code. We have followed our algorithm step by step over here. So now we'll compile and run and see what's the error we got. It's max left. Okay, in line number 49. In line number 49 it should be LEFT. We kept it as LET. No problem. We have corrected this. Now we start compiling again. So we got the desired output. Okay, so now we'll try submitting our code. Okay, it got submitted successfully. So this is the code. I hope you understood this problem. If you do, don't forget to like this video and subscribe to this channel. If you have any doubts, do let me know in the comment section below. I'll definitely help each and every one of you. So see you guys in the next video. Until then, bye bye. Keep programming.